Hello there, Algebra 2. Today we are going to do the exciting work of graphing the sine and cosine functions. So far, we've just been dealing with sine and cosine off of right triangles, and then we extended that to the unit circle. And so today we're going to visually look at what happens if we actually graph those pieces. So there are a couple things you need for today that are included on Classroom. One is this filled in unit circle. You can use the one that you created a few days ago, but we're going to do some highlighting and marking on the unit circle. So I suggest actually printing a piece out. You will also need the graph paper, the blank trig graph paper. We're going to look at sine cosine today. There is also the tangent function on there. That is bonus for you. You can extend what we're doing today to the tangent function as well and take a look if you're interested. The other thing that will be helpful will be to have two different colored highlighters or two different colored gel pens, something to designate some different colors. So we're going to start with our unit circle. And we're going to begin by graphing the sine function. So the first thing we need to do is just actually find all of those sine values off of the unit circle. So what I'm going to do, I'm going to grab a nice pink highlighter. So if you have something in the red genre of colors, you might want to grab that. And I'm going to go through and I'm just going to highlight the sine values that come off of the unit circle. Now remember that at every angle measure, and today we're going to be working strictly in radians. You can also do this in degrees, but in the grand majority of applications, you will see this in terms of radians. So we're just going to graph in terms of radians. So we're going to use these radian measures. Remember, at each radian measure, there is a corresponding ordered pair at where that central angle intersects the unit circle, what that ordered pair would be. And remember that the x value of that ordered pair is the cosine. Cosine's x. And then that y coordinate is the sine function. Sine is y. And so we are going to be looking for those y coordinates for the sine function. So I'm going to take my highlighter and I am going to highlight just the y coordinates. It's challenging being at home because my school supplies are limited to what's in the junk drawer. Do y'all have a junk drawer at home? I feel like I have 5 junk drawers in my house. And so, along with the assistance of my daughter, we found some highlighters. They are not the best, but they'll do. So here I've gone around and highlighted each of the y coordinates. Now those are going to be the outputs for the sine function. The y coordinate will be the output, the y coordinate on my sine graph. The x coordinate is not going to come from here. It's going to come from that angle. The angle measure in radians will be the input for the sine function. The output will be the pink coordinates. Okay, so now we're going to move to our graphs. We're going to keep this handy here because we're going to keep looking at it. Now notice something about those y coordinates. They go from 0 all the way up to 1, all the way back to 0, down to -1, all the way back to 0. And then we could keep going around the unit circle again and again, and we'll see that in the graph. Now, some of these are looking a little funny. I know what 1/2 is, but root 2 over 2 is on a calculator, a decimal approximation, is about 0.707. And root 3 over 2 is approximately 0.866. So I'll want to keep those in mind as I begin to graph. All right, so let's move to the graph here. And I'm going to keep this unit circle handy. It's going to be challenging to try to show you both parts here, but I'll do the best I can. All right, so we are going to start graphing here at 0 radians. Notice along the horizontal axis, what we normally call the x-axis, but we want to be careful with x and y's because they get a little mixed up as we're pulling x and y coordinates off of the unit circle as well. But the horizontal axis has all of those radians. And if you notice, I have split this horizontal axis into those pi/6 increments. There are 6 tally marks between 0 and pi. Okay, so each of these is representing those pi/6 increments. So actually, it's a little bit easier to skip those pi/4s. Not that they wouldn't be there. Pi/4 would be right here, halfway in between. But it's going to be a little bit simpler if we just do those pi/6s. So let's see what happens. Here at 0 radians, my sine value is 0. So I'll have this point right here. Then I'm going to go up to pi/6. Here's pi/6 on my graph. And I'm just going to look for the pink highlighted coordinate. That's 1/2. So at pi/6, I'm up at 1/2. You can see here in my scaling, each of these on the y-axis goes by halves. I'm going to skip the pi/4 just because of how I have my horizontal axis incremented. Then at pi/3, which would be this next spot, I'm at √3/2. Well, that's where I need to look at this decimal approximation here. √3/2 is about 0.866. I'm going to sort of note that. Here's 0.5, 6, 7, 8. It's about right there. So I'm just going to note that so I can find it. Then at pi/2 radians, I have a y value of 1. And then notice that the values start going down again. Here at 2 pi/3, I'm at √3/2, that 0.866. Maybe I'll hide this underneath so you can see my whole graph. Then at 5 pi/6, I'm back to 1/2. And at pi, I'm back to 0. And so I have this nice, rounded mound here. Let's keep going. At 7 pi/6, I'm at -1/2. At 4 pi/3, -√3/2, that's that -0.866, somewhere like there. And at 3 pi/2, I'm down at -1. At 5 pi/3, -√3/2. And you can see the pattern emerging. At 11 pi/6, -1/2. And back at 2 pi, I have the sine value is 0. We have this nice, smooth curve. Okay, we in fact call this the sine curve. But notice my axis keeps going. Well, this would be 2 pi plus pi/6. That would be 13 pi/6. Remember, around the unit circle, you can be more than 2 pi. You just keep going. But those y values are going to repeat themselves. So here is one cycle of the sine curve. And after that, it's just going to repeat itself. 1/2. √3/2. 1. √3/2. 1/2, 0. And then it goes, so it goes above the horizontal axis and then below the horizontal axis. Down to -1, -√3/2, -1/2, and 0. And notice, whoops, sorry, I was off my camera there. Notice that it just keeps repeating itself and repeating itself. How often does it repeat itself? Every 2 pi, because that was one trip around the unit circle. Notice I could take this backwards. I've got a few points here. I could figure out, following the pattern backwards, this would be -1/2, -√3/2, -1/2. And I'm going to grab my pink highlighter since the colors on my unit circle were pink. My sine function relates to all of those pink pieces. And I now have the graph of y equals sine of x, the periodic function of sine. It is always this. This is the parent function, the parent sine function. There are 4 pieces of information that will be important to look at here. One is the domain, one is the range, one is the amplitude, and one is the period. Those are the 4 pieces of information. I will continually ask you about trigonometric functions. So let's look at the domain. The domain is the inputs. Those are the radian measures. What types of radian measures can we have? Well, we can have any and all of them. They will go forever in the positive direction. If I go backwards, they'll go forever in the negative direction. And so our domain is all real numbers because this is a continuous function. It's every angle in between. We pulled off the exact values we knew off of the unit circle, but it is in fact every angle that applies. How about the range? What about those outputs? Well, look at here. We never go above 1. 1 is the maximum of this function. And we never go below -1. We just bounce in between 1 and -1. The maximum value is 1. The minimum value is -1. And so all of those y values sit in between -1 and 1 inclusive. Make sure you have or equal to there because they can in fact have a value of 1 and -1. That is the domain and range of the sine function. How about that amplitude? Remember that amplitude is the maximum minus the minimum divided by 2. I could calculate it that way. Or remember, it's the stretch above and below that midline, that horizontal midline. And can you see that the sine function is cut in half vertically by that horizontal axis, that x-axis. So what is the stretch above that? Well, it's stretching up 1 and it is also stretching down 1. So we will say that the amplitude is 1. And the period length. How long is one cycle of the sine function? Just think of the unit circle. How long does it take to get around the unit circle once? Well, that's 2 pi radians, and you can see that at 2 pi, this graph does in fact begin to repeat itself. So there is the sine function. Now we can do the cosine function. We're going to do the exact same thing for the cosine function as we did for the sine. We're going to go back to our unit circle. I'm going to get a different color. I've got a blue highlighter now. And I am going to look for those cosine values. Cosine values on the unit circle are the x coordinates. So I'm going to highlight those blue so that I remember which values to pull off. I think I need to work on my highlighting skills here. So all of those x values are the cosine. Now, this feels a little bit odd because we're going to take the x values and make them the output values because the radian measure is still the input. So when I go to graph the cosine, the x-coordinate will be the radian measure and the y-coordinate will be the x-coordinate on the unit circle. So we want to take care. That's why it's sometimes helpful to just call it input and output. So the input will be the radian, the output will be the blue highlighted x-coordinates. So let's see what we can do here. Move up to the cosine. Notice the values. Remember, the values are staying pretty much the same. Those 1 zeros, 1/2, √3/2s. And so we're going to see some similar things coming out in this cosine. So let's look here at 0 radians. The cosine value is 1. So the cosine curve actually starts up here at 1. Then I go to pi/6 and it's √3/2. Well, I'm going to mark that one spot there. That 0.866. And again, just because of how I scaled this, I'm going to skip those pi/4s. I'm going to jump right over to pi/3. That has cosine value of 1. Whoops, I skipped too much there. That's why it's good to do it in pencil. Right there, 1/2. And at pi/2, that cosine value is 0. Now I'm going to move to 2 pi/3. That would be -1/2. Skip 3 pi/4. Go to 5 pi/6. That's -√3/2. At pi, we're at -1, and this should start to feel really familiar. This, in fact, feels a whole lot like the sine function, doesn't it? Same values, it's going below and coming back. At 5 pi/3, we're at 1/2. 11 pi/6 back up to √3/2, and then a value of 1 at 2 pi. This looks so very familiar, and it's because of those reflected values on the unit circle. We were dealing with those same √3/2s, 1/2s, and zeros. I'm going to keep going around. I can follow the unit circle again around, or I can just follow the pattern. I'm going to go down, hit a 0, go negative, and back and finish at 4 pi. I can also go backwards. It's easy to see here I was at a maximum, so I need to be headed down. All right, and there is the cosine curve. I'm going to highlight this one in blue. All right, so there we have the sine curve and the cosine curve. They're very familiar and similar, aren't they? Let's look at the domain of cosine. Well, it is continuous. I am using all of the angles again. So the domain will be all real numbers. Look at the range. Again, we're going from a maximum of 1 to a minimum of -1 and bouncing in between. So the range will be the same. The amplitude. Again, look at that midline. I like that midline. What is the stretch above the midline? Well, that's 1. Stretch below the midline, that's also 1. It also has an amplitude of 1. And how long does it take for that cosine curve to repeat itself? Here, if I'm at a maximum, back to a maximum, took 2 pi radians. That should not be surprising because it takes 2 pi radians to go around the unit circle. So what is the difference between the sine and the cosine curve if they have the same domain, the same range, the same amplitude, and the same period? Are they in fact the same graph? If you look closely, there really is only one difference between the sine and the cosine, and that is where they begin. The sine function begins at a 0. It begins at the value of 0. The cosine begins at the maximum. And so that is the most important piece to distinguish between sine and cosine. Where does it start? Sine begins at a 0. Cosine begins at a maximum. If you forget that, think of your unit circle, think of 0, and that ordered pair right there tells you where to start. The cosine, the x-coordinate, starts at 1. That's the maximum. The sine starts at 0. After that, you follow the exact same pattern. So there's our sine and cosine, our parent functions. What I would like for us to do is just look, one more thing, just look, how can we graph these a little quicker? Because this took quite a long time and some exact values. But is there a way that we could speed this up? And the answer is yes. And there are some important and easy points on the sine and the cosine. And those happen to be at those maximums, maximum of 1, minimum of -1, and halfway in between we're at a 0. Those happen to be on the unit circle at those axis markings where everything is 1s and 0s and -1s. If we follow those, we can approximate the rest. So I'm going to go ahead and turn this over, and I want to show you how I quickly graph the sine and the cosine functions. And so you definitely want to practice this along with me. So for the sine function, I draw a nice set of axes. Okay. And I even tend to prefer just drawing them freehand rather than using graph paper. Because I come out here and I think, well, let me start on this vertical axis. I know the sine function has a maximum of 1 and a minimum of -1. So I'm going to draw in those 2 points, and halfway in between is that 0. So that took care of the range. Now I know that there will be one cycle of the sine function in 2 pi radians. So I'm going to come out here and just make a marking and call it 2 pi. Now think of the unit circle. The unit circle is divided into 4 quadrants, and those nice ordered pairs are when we switch quadrants. Those are the boundary markings there. So I want to think in terms of quadrants, or what I like to call quarter points. There are 4 ordered pairs as we go around the unit circle. So I'm going to take this period length of 2 pi and I'm going to divide it into fourths. I'm going to do that by dividing into half first. So that would be pi. And then each of those halves I'm going to divide into half to make quarter points. And honestly, I don't keep marking my horizontal axis. I have enough markings there to figure out that each of those is pi over 2. You can mark them if you want to. Now, I like to, when I'm graphing the sine function, graph 2 cycles. So I'm going to bring those out to another period length, which is 4 pi. All right. So now I have my axes scaled, and I need to think, where does the sine function start? Does it begin at a minimum, a maximum, or a 0? Well, the sine function begins at a 0, so I'm going to plot a 0. And then it goes in the positive direction. So now each of these markings, because I didn't overmark this, are going to be a quarter point. They're either going to be a minimum, maximum, or 0. So I'm going to go up to a maximum. Next point will be back to a 0. Next point will be down to a minimum, back to a 0. Up to a maximum, back to a 0. Down to a minimum, back to a 0. And you can see that those points are going to guide me in drawing my sine function. There are at least 2 cycles of the sine function. And it'll take some practice to get some nice smooth curves. You don't want to zigzag. You don't want line pieces in there. You want a nice rounded curve. Let's do the same thing with the cosine. We know that the cosine has the same domain, range, amplitude, and period as the sine function. So I'm going to have a maximum of 1, a minimum of -1, and the period length is 2 pi. I'll take that out and mark it. I will divide it into fourths. I will have 1 cycle within 2 pi radians. I'm going to extend this out so that I am graphing 2 cycles. That would be 3 pi. And now I need to ask myself, where does the cosine function begin? A minimum, maximum, or 0? Well, it begins at a maximum. So I will start at a maximum of 1. After a maximum, always, since that's the highest point, needs to come down. So I'll go 0, minimum, 0, maximum, 0, minimum, 0, maximum. Those are the quarter points. Connect those for a nice cosine curve. All right, there we have it, the parent functions. What I would like to see for your homework is this picture going through the notes, showing me with your nice highlighting and colors, hopefully, your exact sine and cosine curves with all of those points. Then I would like to see your approximate, just your sketches of the sine, cosine. And then once you do that once more, maybe down here, draw those, take a practice once more so that you can draw sine and cosine quickly. So if you've walked your way through, you are almost all done with your homework. Just draw sine and cosine one more time and send me a pretty picture of your parent functions. We'll begin to transform these in the lessons to come.